Mass flow meter. Volumetric measurements are affected by all ambient and process conditions that influence unit volume or indirectly affect pressure drop, while mass flow measurement is unaffected by changes in viscosity, density, temperature, or pressure. The continuing need for more accurate flow measurements in mass-related processes, chemical reactions, heat transfer, etc., has resulted in the development of mass flow meters. Various designs are available, but the one most commonly used for liquid flow applications is the Coriolis meter. Its operation is based on the natural phenomenon called the Coriolis force, hence the name. Coriolis meters are true mass meters that measure the mass rate of flow directly as opposed to volumetric flow. Because mass does not change, the meter is linear without having to be adjusted for variations in liquid properties. It also eliminates the need to compensate for changing temperature and pressure conditions. The meter is especially useful for measuring liquids whose viscosity varies with velocity at given temperatures and pressures. Coriolis meters are also available in various designs. A popular unit consists of a U-shaped flow tube enclosed in a sensor housing connected to an electronics unit. The sensing unit can be installed directly into any process. The electronics unit can be located up to 500 feet from the sensor. Inside the sensor housing, the U-shaped flow tube is vibrated at its natural frequency by a magnetic device located at the bend of the tube. The vibration is similar to that of a tuning fork, covering less than 0.1 inches, and completing a full cycle about 80 times/section. As the liquid flows through the tube, it is forced to take on the vertical movement of the tube. When the tube is moving upward during half of its cycle, the liquid flowing into the meter resists being forced up by pushing down on the tube. Having been forced upward, the liquid flowing out of the meter resists having its vertical motion decreased by pushing up on the tube. This action causes the tube to twist. When the tube is moving downward during the second half of its vibration cycle, it twists in the opposite direction. The amount of twist is directly proportional to the mass flow rate of the liquid flowing through the tube. Magnetic sensors located on each side of the flow tube measure the tube velocities, which change as the tube twists. The sensors feed this information to the electronics unit, where it is processed and converted to a voltage proportional to mass flow rate. Advantages. The meter is especially useful for measuring liquids whose viscosity varies with velocity at given temperatures and pressures. There are no Reynolds number limitations associated with Coriolis meters. They are also insensitive to velocity profile distortion and swirl. Therefore, there is no requirement for straight runs of relaxation piping upstream or downstream of the meter to condition the flow. Disadvantages. Because the flow tube is subjected to axial, bending, and torsional forces during meter operation, if process or ambient temperature and pressure fluctuations alter these forces, performance may be affected and re-zeroing of the meter may be required.